instance, right? The instance is already running. Now what we have to do is, and it's a managed instance because it was given the role, right? It was attached to role for systems manager. So they can look at the fleet manager here. We see that the instance is managed. Okay. So now what I'm going to do is go ahead and first I want to SSH into the instance, right? So I want to get that my CLI up, right? And I want to get that instance ID, right? Well, actually IP, not, oh, it's right here. Is this one, right? So let me SSH into this instance. I doubted that was, okay, one moment. EC2, let me get the IP address of that guy because that was not the guy, okay? So let me go ahead and SSH. That's why we'll time out because that IP doesn't exist though. So now we have this guy become a, okay, what is this? Okay, become a root user, right? And if I say Docker, it says that command not found, right? Because Docker, when you install it, Docker is a command, right? It becomes a command. So I'm gonna go ahead and install it, right? So Fleet Manager, when I come to the documents part, right? And here, I'm gonna look for Docker, okay? And that's gonna say configure Docker, right? Configure Docker, right? Select that one, perfect. And this will configure an instance to work with containers in Docker. So we run the command, right? We have install, it's gonna install, that's the action. We can install or uninstall, right? If you want to install Docker on 20 computers, you choose install. If you want to uninstall it, you choose uninstall on 20 instances at once. I'm going to choose the instance manually, okay? And comment, I don't have any comments. I'm not going to enable this. And I can go ahead now and run the command, okay? So now it's running the command, right? Okay, so now if I refresh this, it says that it was installed, right? And now I can go back to my EC2 instance and say Docker, and I get a lot of commands here. Okay, so Docker was installed. Okay, perfect. So now let me go ahead and just maybe cat the etc group. Remember that with this, we can see the group, right? So we see that there's a Docker group that was created. See, now what I have to do is, let me take a look at the maybe system CTL status Docker, and we see that it's running. It's running, right? The service is running. So I need to add the EC2 user, which is usually who am I, right? Is the root. Okay, is the root. Maybe we exit and say who am I? I'm the EC2 user, right? So let me go ahead and say sudo user mod, right? And we say AG. And remember, guys, what is this for? Remember that from Linux? What are we doing here? Do you guys know what I'm doing here?
Nope.
Permissions?
No. Guys, I'm adding EC2 user to the group Docker.
Oh, add group AG.
Right. Right. So, well, the A, what means is that I can add this user to a group, but it would not be removed from the other groups. That's the A. That's what the A, which means all, right? So now if I cat the etc, that group again, I will see that EC2 user have been added to Docker, right? Perfect. So now I can have Docker info and get information. Well, I have to say sudo Docker info, and I get information about Docker in my computer, my virtual machine. Containers, there's 0, running 0, pause 0. There's no containers right now. Nothing is here, right? Okay, so we can create now an image. So we can say maybe touch Dockerfile. Okay, so Dockerfile is a manifest that describes the base image to use for your Docker image and what you want to install and running on it. Okay, so we create this file, you say s, right? We have a Dockerfile. Okay, so now we can nano into this Dockerfile, right? And I can paste something from the AWS documentation. Okay, so we can copy this and I can go ahead and paste this. Okay, so we're going to install dependencies. We can install Apache 2, right? We're going to run apt get update and as Apache 2, install Apache and write the hello world message. Run echo hello world. We're going to move it to, remember this guy? We've done it so many times. Configure Apache. So run echo this and all these things that we're doing here. It's going to create an executable, and then executable is going to have 755 to be able to execute it, expose 80, and that's port 80, right? And then the command is root and run this guy. Okay, so now that we have that, build the Docker file from the Dockerfile. So build the Docker image from the Dockerfile. So right now we have this, we save it, right? Exit, right? So we have the Dockerfile now that contains the information. Okay, perfect. We're using here from Ubuntu 18.08. Okay, so now that I have that, the next step is to build an image. So Docker build T hello world. Hello world. So I'm going to create an image. What did a Docker requires like the one argument? Docker build that hello world. Oh, sorry. And the current directory. Okay. So got permission denied, what connected? Now for first I had to be sudo user. So I'm going to type sudo here. And now I got the image that has been created here. You see, it's created the image from the Docker file. Remember the Docker file that I created? It's creating an image from that Docker file. Okay. Okay, perfect. Okay. And remember, you create containers with images. Once we have the image, we can create the container. Right. Still waiting for it. Okay. Perfect. successfully tagged hello world latest. So now we're gonna run Docker images to verify that the image was created correctly. So we say Docker images, and then we say filter. We want to filter the one that says hello world. Okay, because maybe we have 4 images, so we want to get this one only. Okay, so we say sudo, and then we get that we have a repository, hello world, tag latest, image ID created 34 seconds ago, and the size is 196 megabytes. Now that we have that, we're gonna run the newly built image, the -p 8080 that we're gonna have here a map. Well, let me go write it first. So we say do sudo docker run. We're gonna run the image, and then -t -p -p 8080, and that's the port, right? Hello world, right? So the option -p 80:80 option maps the exposed port 80 on the container to port 80 on the host system. So we're gonna have a port for the container and the port for the host system, right? So there is mapping that, right? I say, well, the container is using port 80, well, your host is using port 82, let's map them, right? Now that we have that, we can say this, and then this message. So could not reliably determine the server's fully domain name using set the server name directly globally to suppress this image. Okay. Okay. So now we have to do is simply, well, that's something that is normal. So now we have to open the browser and point to the server that is running Docker and hosting your container. So if you're using an EC2 instance, this is the public DNS value for the server, which is the same address to use to connect to the service with SSH. Make sure the security group for your instance allows inbound traffic on the host. Okay, so let us take a look at the instance. We have using the security group that we're using is the web. Okay, we're now using 80 or 80, so we have to edit the inbound rule, right? We're not using the last level balancer anymore, so we're going to remove this, and then we're going to choose this, and also with IPv6. Okay, perfect. IPv4 and IPv6. So now that we have this, right? We have this. Let us go ahead and grab the IP address of the EC2 instance, right? And let's see what happens. Okay. So we have the EC2 instance, and then we get hello world. You see, guys, we are basically here. We're basically hosting a web application on a container, not on a virtual machine. Do you guys understand what we did here? Right? So we have a container here, and if I'm not mistaken, you can do Docker ls, and no, ls is not a command. So okay, Docker, and then we have a bunch of commands here that we can see here, and we can say Docker images, sudo Docker images, and we can take the image that we have here. We have the Ubuntu image 1804, and we have the hello world latest. So guys, we have a container here, right?
So what's the point of a container? So you don't have to use a virtual machine?
Yeah, it's
kind of confusing to me.
Okay, in this case, we have a container in our virtual machine. Okay, so you don't see much, you don't see the difference that much because we're doing in an EC2 instance, but you could do exactly the same in your computer, right? You can do exactly the same in your computer. You can run here, you can run a container in your computer.
Professor, I guess
Mhm.
what Nathan is trying to ask is, what's the use case? Why and when do you have to?
Self-isolation. Containers are self-contained, right? And also lightweight. So you want to save on resources. Remember the image that I showed you before? Like you need to run a container, an application per virtual machine. Remember, you have to have the hypervisor, create the virtual machine, have the application inside. With containers, you have the host operating system. You have the Docker, which is the container manager, and then you can run application per container.
But in this case, Professor, you are launching a container in a virtual machine. So it's still the same thing. The virtual machine, you're still going to be using a virtual machine.
In this case, you don't see much the difference, right? Because you're doing this inside your EC2 instances. But Docker is a technology that provides the tool to build, run, test, and deploy distributed, and this is a key word, distributed applications that are based on Linux containers. So in the case of Amazon ECS, it uses Docker images in task definitions. We're going to see that if we see ECS, we're going to understand what a task definition is to launch containers as part of a task in your cluster. So what happens is that AWS and Docker, they have collaborated to make a simplified developer experience that enables you to deploy and manage containers on Amazon ECS directly using Docker tools, right? So now you can build and test your containers locally on Docker desktop if you want in your computer, and they deploy them to Amazon ECS on Fargate, which is another service of that. But basically, if we take a look at what is Docker, right? What is Docker? So Docker is a set of platform as a service products that use the OS level virtualization to deliver software in packages called containers. Containers are isolated from one another and bundle their own software, libraries, and configuration files. They can communicate with each other through well-defined channels. Now, when you have your virtual machine, your virtual machine contains how many applications can you run in a virtual machine? Just think about it. How many applications can you run in a virtual machine? Most likely one, right? Most likely one, right? But you can run an application in every container, and every container is inside the virtual machine. So how about that? So you can have containers here, a bunch of containers, like 10 containers, and run an application in each container and still be able to see it. Still be able to see it in your virtual machine. It's kind of confusing because you are doing it inside a virtual machine, but when you use ECS, right, you may see it better, right? But
anyway, it's kind of clear now, Professor.
Yeah, it's isolated from each other. I can have several images here, several containers, and they have nothing to do with each other, right? And you can run applications inside the containers, and the container contains everything that you need to run the application, right?
So is it just better security or something?
I'm sorry?
Is it just used for like better security or something?
Yes. Yes.
Okay.
When they're set, yeah, they don't depend on each other. If one container
I still don't see what the point of a container is.
Yeah. Yeah.
And also, I think when you want to launch like a lot of applications, I think so. Because
yeah. You see, let's see. Continuous virtual machine. Do you have here? This is a virtual machine. Look at that. Host OS, and then hypervisor. Look at this. More work. Virtual machine, virtual machine, virtual machine. Right? Containers. host OS, your computer, right? Let's forget about EC2. Your computer, your host OS, right? You install Docker in your computer, and then on top of Dockers, you can run 20 applications in 20 containers. You see that?
What applications?
So, any application, a website, a web application, maybe a full stack application.
So this doesn't have to be in the cloud. Like this is just
correct.
Extra security layers, right?
Well, actually, it's virtualized. It's in the cloud, but it doesn't have to be in AWS, right? Docker, the concept of containers is not an AWS concept. That's a cloud concept, right? Containers are virtualized. They're virtualized. They're not like a bucket, like you have in your house a bucket full of waters. It's just virtualized. But instead of virtualizing your virtual machine, like you virtualize the containers, right? But look at this, you are exhausting less resources than here. Here you have to create a virtual machine per application. Here you have on top of Docker, you have a bunch of applications here.
And you said, Professor, that ECS is the equivalent of Docker for AWS, right?
No, ECS is a service that works with containers. It supports Docker. You can work with Docker using ECS.
Okay. And right? ECR is the registry one. You said it's for images, right?
Yeah, this is an image, right? Hello world, right? If we were to work with ECR, we would save this in ECR. You save the image there. It's a registry for images. It's called Elastic Container Registry. How do you create a container? You have to build an image, and that's what we did here. We build an image, right? All of this here, there are all a bunch of things here. We'll build an image. Let me look for that command right here. We'll build an image, right? And we name the image Hello World, right? So that will create an image for me. And with that image, I can create containers. And we're basically hosting a web application in a container, right? The Hello World application. Go ahead.
Yeah, can you scroll up a little bit? There was, no, you're going too fast. There was.
One moment, let me go back. Okay. Tell me.
I mean, there was a line with a 80-80, like trying to map the container.
Okay. Yes, right
can
here.
You explain it? Can you explain
the container has a port, and your host operating system has a host too, has a port too. So you're
like
mapping.
EC2, like.
Correct. In this case, the EC2 instance. So remember that we open port 80 in our EC2 instance. So this is mapping the container port to the port in our EC2 instance. That's why we're able to see in the browser, Hello World. So this is not that easy to understand it here, but when we see, if we see containers, ECS, because I have some examples there to display something beautiful in the browser as well, we will have to do the mapping. The good thing about, if we have an Elastic Load Balancer, the good thing about the application load balancer is that it has dynamic port forwarding. It means that we can leave this blank, and no matter what port the container has, it will map it to the instance. That's the good thing about application load balancers, right? In this case, we don't have a load balancer, so we have to specify what port the container has and what port our EC2 instance is using to display the text in the browser. So we have to map it. This is what this -p does, like port 8080.
So in the case where we have a load balancer, we don't need that.
If it is an application load balancer, because that's the only load balancer, that has that feature.
Okay.
Right?
Thank you.
If it is a classic one, we still need to use this. But this is done here in the CLI because we did it inside but you can use ECS from the console and do it there, right? Something similar, right? So guys, Docker is a platform. By the way, it's platform as a service, right? Go back here. It's platform as a service, right? PaaS. A set of platform service that use OS level virtualization. So you're basically, instead of virtualizing the virtual machine, you're virtualizing the OS, okay? To deliver packages called containers. So it's a package. We call it container, but it's basically a package that contains everything, libraries, binaries, everything that your application needs to run. And by the way, it was created in Go. Go is the language of Google, right? Docker, it was a developer, and it's been around since 2013, for 8 years now. It's very new, okay? What else can we say about Docker? So maybe Docker overview. Docker is an open platform for developing, shipping, and running applications. Docker enables you to separate your applications from your infrastructure so that you can deliver software quickly. So here, if you guys don't understand what is the use of what the use of Docker is yet, you can read the documentation here and you see. So with Docker, you can manage your infrastructure in the same ways you manage your applications by taking advantage of Docker's methodologies for shipping, testing, and deploying code quickly. You can significantly reduce the delay between writing code and running it in production, right? So Docker provides the ability to package and run an application in a loosely isolated environment called container. Loosely isolated because they don't depend on each other. If it says tightly isolated, it means that they're connected to each other. It's loosely coupled. Okay? They're not linked. Okay. The isolation and security, okay, allow you to run many containers simultaneously on a given host. So you have one host, OS, and then you have, on top of that, you have many containers, and each container has an application. Okay. So containers are lightweight. That's what I said before, the lightweight, and contain everything needed to run the application. So you do not need to rely on what is currently installed on the host. Okay, so you have to install many things if you run an application in your computer. So remember that we created a Python code. We have to install Python. We have to install pip, all that, right? So if you have a container, you don't need to install any of that, right? You can easily share containers while you work, and be sure that everyone you share with gets the same container that works in the same way. Docker provides tooling and a platform to manage the lifecycle of your containers. Develop your application that needs supporting components using containers. The container becomes the unit for distributing and testing your application. When you're ready, deploy your application into your production environment as a container or as an orchestrated service. This works the same whether your production environment is a local data center or cloud provider or a hybrid of the two. Okay, so, and then you can continue reading here the advantages of Docker containers. Okay, so here we have a registry. This is when you have the images. This is the client. You can use this Docker build, Docker pull, Docker run. Those are commands. And then you have the Docker host, the Docker daemon. You have to have that installed. And then you have the containers and the images that come from the registry. And the registry is Docker Hub, right? From here, Docker Hub, that's when you get the images, right? And my Docker is running right now is running. If you take a look at my VS Code, I have Docker in my VS Code as well. So let me see here. It's right here. This is Docker. Docker here as well, right? So I have done some things with Docker, right? I can just connect a registry that can be in Azure, Docker Hub, and I have an account there, enter your Docker ID. I think I have a Docker ID. Let me see my account, the dashboard. Let me see, Dunieski Optano. I don't have here Dunieski Optano, Docker ID. I don't have any. It's asking me to upgrade it. I'm not going to upgrade. So, yeah, Dockers are super, super, super important. When I went to, when I worked the web